Foundations of Amateur Radio. For some time now, I've been discussing the potential of weak signal propagation and its ability to create a live map from the data that your own station transmits. There are several systems in place that show a map of where and when your station was heard in the past little while. Using 200 milliwatts, I've been transmitting a WSPR or Weak Signal Propagation Reporter beacon on 10 meters for the past few weeks. At the moment, the furthest away my beacon has been heard is 13,612 kilometers away. That's an 0.2 watt signal heard on the other side of the planet, on 10 meters. As distance goes, it's a third of the way around the globe. I must point out that there's no way of knowing if this signal travelled the short path or the long path. If you've heard those terms, short and long path, but were wondering what they mean, here's how it works. If I get on my bike at my QTH in Perth in VK6 and pedal east until I hit Sydney, I'll have crossed Australia, taken about 184 hours, and travelled about 3,746 kilometres. That's the short path. If I head west instead and start swimming, visit Cape Town, Buenos Aires and Auckland along the way, I'll have travelled much further, still made it to Sydney, but taken the long path. Radio waves can do the same. Depending on propagation, a signal might take either the shortest route or go in the opposite direction and take the longest route along the Great Circle between two stations. I'm mentioning this because WSPR doesn't tell you if it's one or the other, and if you're using a vertical, it could be either. Even directional antennas might receive a signal from unexpected directions. Using one of the mapping tools, WSPR.live, I extracted all the sightings of my call sign and all the reports that I'd made from my receiver. It shows that my newest transmitter has now been heard by 11 stations across 3 continents. Those numbers are just the beginning. I wanted to see on the map where these stations were, so during the week I built a proof-of-concept world map that I used to visually show the 4-character Maidenhead grid squares that my station was heard in. I also had a look to see which stations I'd heard over the years and where they were. In all, 771 different stations are in my log, either as a receiver or a transmitter. November 4 Whiskey Quebec Hotel heard me on 40 meters, 18,832 kilometers away when I was using 5 watts. My station has heard or has been heard across 331 different grid squares. There's reports across some remote parts of Australia, Japan, India, South Africa, Europe, the United States, several across the Pacific, and even a few in Antarctica. I wondered how many of the world's grid squares have actually been activated, and which station was heard the furthest, and how much power was used. Those numbers will have to wait for another day. I initially started using WSPR.live, which has a neat way of allowing you to embed an SQL query as part of the URL to download the output. I was getting some interesting results, so I thought, rather than hammer this lovely resource with my questions, I should download the raw data instead. So I did. Well, I am. Still, it's big. As of today, there's 166 files taking up 60 gigabytes of compressed data with over 3.5 billion reports. The first spot in that data goes to November 8 Foxtrot Quebec, who heard Whiskey Bravo 3 Alpha November Quebec on Monday the 17th of March 2008 across 911 kilometers on the 30-meter band, transmitting with 28 dBm, or about 630 milliwatts, reporting a signal-to-noise ratio of 1 dB. Using preliminary data to get started, I mapped all the activated squares, each shown as a red box, and saw that my entire map was red. At that point, I figured that either I've got a bug in my code or something else is going on. To give some context before I share what I found, a Maidenhead locator consists of a combination of letters and numbers. For 4-letter grid squares, there's a grand total of 32,400 different combinations, running from Alpha Alpha 00 to Romeo Romeo Niner Niner. They're 2 degrees wide and 1 degree high, and their width depends on where on the planet they are. At the equator, it's about 221 kilometers wide and 111 kilometers tall. At the North and South Pole, it's 0 kilometers wide. If you travel between 2 squares, you might have to move a meter, or the entire width of a grid square. Among the report, I found stations who had activated more than 1 square. That's fair enough. You can move your station and start making noise wherever you like. I found stations with activations across more than 1,000 different squares. Before I start pointing the finger, I will mention that if you attach a whisper beacon to an aircraft or a balloon, you can legitimately activate plenty of squares. When you set up a whisper transmitter, you're required to manually enter the locator, and mistakes happen. There's plenty of records with invalid Maidenhead locators. Typically shown instead is a call sign. Then there are stations that pick desirable locators. This manual entry is also true for the power level and even the call sign. So I'm not outing these stations here, since it's entirely possible that the call sign shown doesn't actually relate to the transmitter or the licensed amateur. What does all this mean? It means that the information in the Whisper database cannot be trusted. I suspect it also means that the data used to lodge FT8 contacts across the planets can probably also not be trusted. It means that any propagation data you're deriving is likely contaminated by misreporting, deliberately or not. As a community, if we want to use this for actual measurements, we'll have to find out how to make this a trusted resource, because the information that Whisper can bring to propagation is, in my opinion, extremely valuable. I would love to hear your thoughts on how we might fix it. I'm Mono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.